What makes Wi-Fi 6 better? Why fall in love with Wi-Fi 6? There's a couple underlying technologies I want to talk about. So admittedly, we're going to geek out here for a bit, but stay with me because these are the reasons Wi-Fi 6 is better. And these aren't the only advancements, but I believe these are the key advancements. The first being OFDMA. It's a mouthful, so just go with it. OFDMA, OFDMA, OFDMA. OFDMA, though, gives us all the benefits you see listed here. So things like optimized packet scheduling from the clients and APs, gives us improved efficiency, which gives us higher data rates and eventually improved performance even with higher client densities. And it allows for those higher client densities as well. The second piece is target wake time, and which we'll get into in a bit, but now your devices don't have to talk as much because they've scheduled a time to talk, and so this allows for improved power efficiency or battery savings. Let's dig into OFDMA though a little bit more to see what that looks like. So here are two graphs. On the left, you see technology from a traditional network that relies on sending packets using OFDM. Now, basically, each client is given a chance to speak. Let's see, I think I've got a laser pointer here. We'll try. So each client is given this chance to speak in an individual allotted amount of time. So time bank 1, time bank 2, time bank 3, maybe client 1 speaks here, client 2 speaks here, client 3 speaks here, so on and so forth. Now, we can technically, this is a bit of a simplification. We can talk to multiple users at the same time using technologies like MIMO and MU-MIMO. Some of you may have been thinking that. But eventually it boils down to that airspace is occupied by one person at a time. On the right, you see a slightly different graph, OFDMA, where each time block can be subdivided into these kind of sub-intervals. So it's actually 78 different sub-intervals to be exact. Wi-Fi 6 supports 78 subchannels, which is important because not all packets are made equal. When I first look at this graph, at these two graphs, I thought the left and the right look pretty much the same from a throughput perspective. But then I realized what was going on here, so I redrew this graph because, actually I'll back up. This assumes that each client is sending a full packet's worth. Let's say each of these time blocks is worth 100 megs of data. But what if I only want to send 2 megs or 10 megs or 25 megs? That leaves the rest of that time block unutilized. So now you can see the difference. I've wasted a ton of space on the left. I need to maximize the use of my airspace, and OFDMA allows that by having these subdivided channels. Clients can talk more frequently and in smaller bits, and we still get to use all of the airspace allotted to us. Now, what I do with that extra airspace is up to me. I can have bigger packets, like we talked about with AR and VR 4K video streams, and send more data. I can also have smaller packets and support more clients. And Wi-Fi 6 gives us more bandwidth to work with in either of those instances, and gives us more control of how to use that bandwidth. And that's borne out in some testing. So here's a graph. On the left, you can see our users are increasing, but at the same time, latency is increasing. So this red band is 802.11ac, Wi-Fi 5. The blue band down at the bottom here is AX. And even as our users increase, even as more people hop on the network, we're not slowed down. With traditional Wi-Fi 5 and previous generations, more people hop on the network, we go slower. And then on this graph, you can see we actually send less data. The light blue bar is Wi-Fi 6. So it doesn't have near the impact that previous Wi-Fi generations do as you add more users. And this is mostly thanks to OFDMA. OFDMA is actually borrowed from cellular technology, so I'm betting most of us have experienced this already. You know, you're in a mall or an airport or a crowded area, maybe that's been a while thanks to our pandemic and social distancing, but the Wi-Fi grinds to a halt all of a sudden. So what do? You flip over to cellular, and all of a sudden your Twitter feeds, Facebook news, streaming audio kicks back in. It's because cellular technology relies on some of those sub-channel divisions already to work with higher client densities better. So let's move on to our other game changer, targeted wake-up time.